Introduction to Machine Learning. Machine learning is a technology that enables computers to learn from experience or past data and therefore become adept at predicting outcomes. Let's understand this with an example. Here's an image labeled as a human. When this image is fed to a machine learning process, it learns that the figure has two legs and two hands, and it is called a human. Here's an image labeled as a horse. To a machine learning process, this has four legs and no hands, and it is called a horse. And this image is labeled as a bird. To a machine learning process, this has two legs, wings, and a beak, and it is called a bird. And this is labeled as a fish. To a machine learning process, this has no legs, no hands, and has fins. So, our machine learning process creates what is known as a model that has been trained to recognize what a human, horse, bird, or a fish looks like. Now it's time to test our machine learning model. This is our test image that our machine learning model has never seen before. It analyzes the image and finds it has two legs and two hands. Therefore, it must be image of a human. The accuracy of prediction will vary based on how different this image is from other human images our model has seen before. Now let us test with this image. Our machine learning model identifies this as a horse, which we know is wrong. Our model has never seen a dog image before. Therefore, the closest match it can find from experience is a horse. After all, it has four legs and no hands. So how can we correct this? We need to train our model with dog images so that it knows that other than four legs, dogs have short tails and a distinct face structure. So how is machine learning different from artificial intelligence and deep learning, all related fields? AI is the overall science of a computer being able to mimic human behavior, while machine learning, which is a subset of AI, is the science of learning from data to find patterns in them, which can then be used to predict with new data. Deep learning is a subset of machine learning. Here we are talking of neural networks, kind of artificial representation of how human brain works. It could be used for computer vision, speech recognition, etc. So, in the machine learning world, you feed historical data to a machine learning process. It examines it to find patterns using various algorithms and outputs a machine learning model. A machine learning model is simply a program that has been trained to recognize certain types of patterns. Here's a concrete example. Our training data is a large dataset with features or columns like longitude, latitude, humidity, temperature, and whether it will rain or not. This data might be of last many years, therefore useful for training our model. Our machine learning process learns from this data. In other words, it figures out whether for a certain combination of values of the feature set, will rain would be true or false. For example, when temperature is low and humidity is high, will rain would be true. In general, larger the training data set, better the learning, therefore more accurate the prediction. Here's what a typical machine learning workflow looks like. Historical data is first cleaned, whereby records with incomplete or missing data, duplicate records are removed, and inconsistent or bad formatting is corrected. Next, data is prepared. Here it may be split into training and test data. Post that, machine learning program processes the training data and creates a machine learning model, which is then evaluated using test data. The results are examined to tune the machine learning process further. Here's an example of training data. You can see that there are duplicate records here. Size values are inconsistent. Sometimes abbreviation of M or S is used instead of medium or small. And then there are some fields which have missing data. Temperature has inconsistent decimal formatting. These inconsistencies must be cleaned up before this data can be used for training ML models. Learning part in machine learning can be broadly categorized as supervised, unsupervised, and reinforcement. In supervised learning, input data is labeled, while in unsupervised, it is not. And in reinforcement, an agent or a computer program performs actions and learns from positive or negative feedback from its environment. Here's an example of supervised learning. Input dataset has clearly labeled images of apples and mangoes. Our machine learning process learns from this and creates a machine learning model. Therefore, when a new mango image is fed to the model, it is able to identify it as mango correctly. Now contrast this with unsupervised learning. Here our input data consists of a bunch of unlabeled shapes. Our machine learning process tries to find patterns in this data and successfully identifies similar shapes. So here we can see that unsupervised learning is useful in finding data clusters in input data. Here is a quick look at some machine learning algorithms. There are many of them and each suited for some use case. Your machine learning process will make use of one of them, or you could write one of your own. We will not go over them here. They deserve a separate discussion of their own. So what are some examples of machine learning? A financial services company can use machine learning for fraud detection based on customer usage patterns. In healthcare domain, it could be used to predict disease reoccurrence based on past patient data from healthcare providers. An e-commerce company can recommend products to customers based on his past buying patterns and those of other similar customers. And a ride-hailing company can arrive at surge pricing model. Before we end our discussion, here is a question for you. What is meant by data cleaning in machine learning? And why is it important?